Okay, I'm going to go over this problem, chapter 6, problem number 1 for your assignment, because I get a lot of questions on this particular problem. So it's asking us to write a program to calculate the parity of a 32-bit memory operand. So it has to be a variable. And it gives you the formula. The formula for calculating the parity of a binary number is to do an exclusive OR. So you're going to XOR all the bits together. And we're going to test it with 2 double words. And then we're going to display if it's odd or even parity. So first of all, we know it's odd or even parity depending on the number of bits. So if you have an even number of bits, like the number, let's see, 10. So the number 10 would be 1, 0, 1, 0. So that's an even number, even parity. And if it's 11, zeros, 1, 0, 1, 1. This is the number 11. This would be odd. So what we want to do is we want to create a variable like val1, make it a double word, and assign it. Let's say if we assign it a 10 in decimal. Again, 10 in decimal is this, so it would give us an even parity. And then if we assign it this, we should get odd. So this is going to be a double word. So right now, this is just 1 byte. So if we have a 4-byte number, we're going to look at it this way. So we have 4 bytes like this. So this is our first byte. This is our second byte, third, and fourth. What we want to do is we want to XOR these 2 bytes together. And that's going to give us an answer. Whatever answer that gives us, we're going to XOR that answer with the 3rd byte. And whatever that parity is, we're going to XOR it with the 4th byte. So to get to each one of these bytes, let's say this is val1, okay? To get to each one of these bytes separately, we're going to have to use something you learned in chapter 4, which is using a byte pointer. Okay, so this is just 1 byte right here. So this would be like this 8 bits would be here. And then I would need another 8 bits here, and another 8 bits here, and another 8 bits here, okay? So it would be 32 bits to make this val1. So if I wanted to get to this very first byte, I would say byte pointer. This might be better if I just type it. I'm sorry. I would just say byte pointer val1. So val1 is the name of my variable. That gets me this first byte. And then if I want to get to the second one, I'll do byte pointer val2. So when you XOR, you've got to have here on this left-hand side, you need to have a register. So you can have like AL or BL or AH or whatever. So you have to move this first one to a register. So you could move the very first byte to AL, and then you can XOR AL with the second byte. That answer is going to go into AL. And then you take that AL and you XOR it with the third one. So it'd be byte pointer plus sorry. This is by pointer 1 plus 1. It's 2. So this gives you the second byte. This gives you the third byte. And byte pointer val 1 plus 3 gives you the fourth byte. And this is the first byte. So to XOR something, you would XOR, you need to have a register here. And then whatever byte you are going to be XORing it with. But this is how you get to each one of these. And you're just XORing first byte with the second byte, the answer of that with the third byte, the answer of that with the fourth byte. So it's going to end up being 4 separate statements. And the very last XOR will give you either even or odd parity. So hopefully that helps explain it a little bit more. And then to test it, you can just put a number like a 10. That will give you even parity, or 11, that should give you odd parity. You don't have to put a long binary number of 32 bits. You can if you want to, but you don't have to. Okay, hopefully that helps. Thank you.